Get started, I'd like to go over a few items so you know how to participate in today's event. You've joined the presentation listening using your computer speaker system by default. If you'd prefer to join over the telephone, just select phone in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenters by typing those into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. Today's webinar is being recorded and you'll receive a follow-up email within 24 to 48 hours with a link to view the recording. I'd now like to introduce your presenter for today's webinar, Edward Yang, Senior Director of Engineering at PDF Solutions.
Hi, everyone. To start, as a public company, so we are required to have the safe harbor statement. We can go next. My name is Edward, and I lead the field application teams at PDF. I started my career in semiconductor in late 90s, and I've been using PDF software since 2000. So I've been with PDF for the last 17 years. With me today is Benjamin Muller from Advantest. Benjamin leads the Advantest Cloud solutions. Next. Okay. This is today's agenda. We will start with semiconductor manufacturing analysis challenges. Throughout the presentation, you will hear me refer to PDF Exensio, which is a PDF's big data analytics platform built on industry-leading technologies for design and entire manufacturing flow. Next. Okay. In today's competitive semiconductor industry, many companies are facing various challenges. For example, rolling out new products, they need to ramp up the yield fast to enter the market. They compress the NPI times and still need to keep the good quality. At the same time, for the mature products, we need to quickly identify the root cause of excursions or low yield analysis with increasing volume and type of data. So the need of AI becomes essential. However, the different formats of data, how do we build a relationship between data and specific analysis needs often create barriers for success implementation of a big data analytics system for those companies. Okay, next. So there's a universal awareness that this digitalization will actually drive a huge growth in data volumes. We see more tools. Right now we see in the mega fabs, we have thousands of tools. We see more sensors. We have some equipment collecting thousands of sensors now. We see advanced 5G or AI chips with more than 100,000 tests. And some applications, they need to store the data for much longer period of time, like 7 to 10 years. Okay. Huge amount of data also need manipulation, and AI is needed to help manage the data and derive the real value. So the drive for the industry 4.0 and the drive for digital transformations will be built on the connectivities, on data, and of course on the actionable intelligence that is derived from the data. Okay. Next. As technology advances, the process and testing in semiconductor becomes more complicated. In the backend, we see the system in package, we see the fan-out process, we see the chiplet. In the last few years, we also see the chip compatibility issues that require additional integration due to interface standardizations. The data integration also becoming more complicated. So at the same time, PDF is driving the industry standard and the chip. We also see a chip security also becoming an issue for certain applications. Okay. Next. So with more data collected, these are often not ready for analysis. So for example, when we work with the fab, we often see the wafer WEH chamber sequence is not easy to analyze. And wafer can go through many processing paths. With a rework, with a split lot, it's very difficult to align the data for statistical analysis. A wafer can have a different sequence and a number of steps. Conventional analysis method now can no longer find transition impact on yield, especially when the same tool or chambers are utilized multiple times, especially during the backend process. So how do we establish a material tracking? This is difficult for various source and complicated supply chain. Okay, customer return product is also very difficult to trace back to assembly or to wafer fab to identify the root cause and to prevent the trouble happening again. Okay. And some traceability implemented today is only supported one way. Next. When we collect more data, we also see a lot of what we so-called dark data. What is a dark data? Dark data in semiconductor are those information or data as collected and processed during the manufacturing process, but they fail to provide information. Okay. We see 25% of this kind of data not providing information because it's very difficult to use, because the data is not aligned, because the data is redundant. We see additional 60% of data from a typical fab that almost never used or used only once, maybe for alarm, maybe for OCAP, but they're stored in your storage for 1 year before they got purged. But and then this usually consumes majority of the storage space. Okay, next. Some example of dark data, right? Dark data is not used because one is unstructured. It has huge volume, it's so huge, so it's very difficult to analyze it. And the other reason is very difficult to align with other data sources. Some example, for example, right now with the equipment log data, we know there's a lot of information from equipment log, but because the log file usually is non-structured, and it's actually a huge amount of data. So it's very difficult to analyze from the log data. Okay. However, the log file that generated by equipment or from the operator or engineer enter information, we believe this can be used to predict equipment troubles. We also see a lot of image files, for example, from optical inspections or from inline metrology or defectivities. These kind of image files, we can use AI or machine learning method to dig it. So conventionally, these are only like for review purpose, but not for much analysis purpose. We also see more environment or facility data, like the pump data we collected during the process. These are often only applied to equipment, but we can use a machine learning or use AI method to align the data with other type of with the material data. Okay. Next. So now we'll go to the a poll. So think about the data you collected or available during your manufacturing flow. How many % of data you would consider a dark data? Either you cannot collect, or you collect but you cannot really analyze, or you analyze the data but cannot really get a value out of it. All right, let's see what's the poll result. Wow. Okay, so is majority of the attendees says, yeah, so this is pretty much aligned with what we see today in the industry, with 51 to 75% of data cannot provide good information. Thank you for the poll, and we can continue. Okay. So one way to utilize this is now let's talk about why a semantic data model is needed to enable advanced analysis. Okay, next. So what is in PDF has become a domain expert over the last 30 years in understanding the design, the fab manufacturing data, the parametric test, the sort, assembly, package, and system level test, all the way to the in-field monitoring data, and how to link this data together in a semantic model so the data can be aligned and can be ready to analyze. Okay, we also found that ingesting and building a data model requires a big data platform to enable analysis-ready data, and spent the last 10 years building our capable of handling the variety and velocity of data, with addition to AI and machine learning to link the online control system, we can provide a smart manufacturing solutions. Next. Okay. So one of the example of instead of dark data, how do we build a semantic model that can turn the dark data into information? So two examples from the typical fab. One is so-called offline metrology. Offline metrology are, for example, the particle wafers or some data that only tied to equipment, but not tied to any product. So we can take the offline metrology, we can align the data with WEH data or MES data, then we can assign to a product data. At the bottom, we also have some, for example, equipment event data. So instead of the data we get usually is equipment, what time and what event. But by comparing the data with wafer equipment history from MES system, or sometimes from the FDC systems, then we can convert the data, use a semantic model to turn the data into for this material, when was the last time the event happened? So time from the previous PM. So now we can align this data. So by applying a semantic model to the typical dark data, this kind of analysis can be done in minutes instead of days. Okay, next. Another example is what we mentioned about wafer equipment history. So aligning the wafer equipment history becomes very difficult in an advanced process because there's in-situ rework. Some wafer in a lot goes through certain metrology inspections, some doesn't. So every wafer has a different process conditions and a different path. So instead of spending the time to align all this data together, we can actually implement AI modeling called PES AI, Exensio PES AI. Then we use a machine learning to identify the sequence or the transactions that leads to failures. So we can look at lot level or wafer level, step-to-step transition and dependencies between tools and chambers. Okay. By looking at the step transitions, PES AI can find the multivariate failure signature that often other machine learning techniques could have missed. Okay. Next. By applying semantic model and also a traceability, we can make RMA solutions much easier. When you have a customer return, we can trace it back from a particular device to system level testing to the final test. Even this is system in package product, we can trace back to the different substrate. We can trace this back to the test done on wafer sort, final test. We can trace back to WAT. We can trace back to the fab. We can even trace back to the FDC data, either from assembly FDC or the FDC data collected during the wafer manufacturing. Okay, And to achieve the RMA, we need a semantic model and traceability enabled, so we can do a fast RMA management. Next. So previously we talked about couple semantic model applications. Now to achieve this, we'll talk about which kind of data collection is required. Next. So coupling the Exensio big data environment, we capture all these data types with the PDF cloud that enable the complete end-to-end analysis-ready database. We have a best-in-class cloud environment accessible from anywhere in the world. And then we have lightweight sync-client protocol reduced latency. The same user experience worldwide. So we have rich cloud-enabled machine learning drive analysis not possible at production scale without cloud technologies. Okay, next. Okay. PDF is not just like data warehouse. Exensio also do a lot of data collections. We running with more than 300 front-end fabs, test, and assembly tool models. So we work closely with the process equipment. We also have huge experience with more than 50 vendors and 150 equipment models in assembly. We also have very tight collaboration with Advantest, and we also support other test platforms. All of the biggest platforms in the industry are represented here, and we also continuously adding support for both new and legacy platforms. Okay, next. So with a tighter integration with equipment, including process and test equipment, more than 40,000 deep agents are deployed around the world that allow us to collect more complete data. It's already enriched in most cases using PDF agent on the equipment that we can push configuration, rules, and online and we can also collect online real-time data that we can access online data and do the control in the real time. Okay. With collaboration with our partners, it allows us to easily set up and access to new equipment and new type of data access. Next. Not only with existing equipment, PDF yesterday we announced the acquisition of Symmetrics. So now we can enable more new connectivities and control for the manufacturing equipment. Now we can collect more data, we can collect higher frequency data, and we can also ensuring the data collection quality is much better. We also can enable equipment that we could not collect data before. Okay. All this equipment connected from the design to fab from the test, assembly to final test to system level testings now can be collected through the Symmetrics data collection products and fab automation products into Exensio Analytics Platform. Okay. Next. PDF is also committed to an open environment for strong support of industry standard. We support the test data collection with CAST. We also collect the test event message for semiconductor attempts. We collect SLT and component SLT. We also support the SEMI T23. This is for the single device traceability. This is for security that we mentioned earlier. And then also SEMI E542. This is mainly for traceability of raw material in a package. So you can collect very detailed package information through E142. In addition to this, we also support E30, E5, E37. This is mainly for 6Gen HSMS collection. In the more advanced equipment, we also support the EDA or interface A data collection. This is for the high-speed data collection. Then we also support the EPT, MPT, and then E39, E40 for the OEE. And for the collection securities, for the data collection management, and also E164. This is pretty important for the new metadata collections. Okay. Next. Other than this industry standard data, we also, PDF also provide differentiated data through our proprietary DFI. These are the inline e-beam inspection tool. PDF also has a very strong CVI infrastructure on the e-test. And we also have a CV core, which is we can implement on the product that we can collect the data even the product is on the system or in the field. Then this kind of differentiated data we can collect through the interface and then fit into the Exensio Analytics Platform. So you can align this data with the rest of the data you collected from the fab, from the product, or from the test. This gives us a much better reliability. We can go to the DPPM, and we can also do predictive fail. This also lower the cost and improve the performance, especially on speed and power. We also support this even few years after the product goes to the system through our CV core. Next. After all these analysis and data collections, the next thing we want to do is to do prediction and control. Okay, next. Okay, so in the early 80s or 90s, the industry we're in is still in the data collection stage. Right? Analysis was done through a standalone software like spreadsheet, right? And for engineering experiment. Then over the years, in the late 90s, the digitalization of these sensors, for example, the Semi-E10 standard to start to enable the sensor data to be integrated with other data types, leading to the incorporation of the feedback and closed-loop control, such as like SPCs, run-to-run, feed-forward feedback system. So this is when we move into the diagnostics era. Then we start to build the data hubs that enable the multiple data types to be aggregated across multiple sources and steps, enable the multivariate analysis for process optimization, and we start to see the benefit of digitalization. Okay. Now, as a big data platform being implemented, we are seeing across company integrations. Like we collect data from multiple offset, we have multiple products, we have multiple suppliers, and then we can start to benchmark different fabs, different offset. And we start to do the standardization, automation, and advanced analysis to handle large variety type of data. This is not only provide a value, but also innovation and business growth. Now, at the bottom you see we are in an era of from machine learning AI stage to the product machine learning AI stage. What's the difference between the AI machine learning and product AI is now we move from the hub, such as like a data lake, into a data platform like Exensio, where the data is pre-aligned and a semantic model is applied. This allows the AI and machine learning to run without humans. We can fully automate this. This is when we can start to realize the value from analytics, from automation to process, instead of you don't need to rely on the AI experts. Now, if we can remove the humans, we can scale up a business much faster without needing to add people to add a business. So when the data is pre-aligned, a model applied, the system can talk with equipment directly, no matter where they are. So for example, our DEX node. We can now automate this process like outlier predictions, like screening with AI models and scale up business much faster. This is when we get the biggest return on the AI and machine learning. Okay, next. Next. All right, another point. So now think about what we just described from diagnostics, and from descriptive for prognostic. So think about your where you are on your digital transformation journey. Okay. Okay. So we see majority of people is either from diagnostics, means like just collecting the data. From the data collected, you're already doing the analysis, doing some, for example, round-to-round stuff, and or from the data collection to enable from the descriptive to diagnostic period. So this is also aligned with what we see on the industry. Okay. Next. So now we also see a real time becomes necessary, right? So this is an example how we can see a real time tester status through our DEX node. So an engineer sitting in California now can see all the offset his products running either in Asia or in other locations. What's the status of the equipment with like in the real-time data, right? So engineer can take the real-time actions, or the AI modeling can take real-time actions. Next. So this is more detail. When we click on the report, then you can see the equipment state, the material state, and the test result in real time. Okay, next. Okay. So one of the application is die-level sort predictive engine. So when we talk about a digital transformation, this is one good example of what we call a strong AI. Okay, because to do the predictions, we need the data from some from design extractions, we need data from the fab, and then we need the data from the wafer sort. Okay, the volume and variety of the data make it nearly impossible for human to understand all the interactions. So the AI and big data can handle the volume and variety and find the insight that human could not. Okay, so for example, the die-level sort prediction engine, this is one example of what we call strong AI that we deploy with the customer. Next. So PDF Cloud is not just a lift and shift for existing system, it's also a foundation to ground up big data. Right? So this, go to next. In this example, we collect the data from the offset and train the data in California. And after training the data, then we can deploy the inference engine into the edge. Go to next. And next. So once the model is built, and then the model can be deployed on the edge, these reduce the data loss possibility during the data transfer, and also improve the data quality. Also, the inference engine at the edge can allow user to develop their own models and latest machine learning technologies. Currently, the inference engine are deployed in several major offset subcontractors and customers. Okay. Next. Next. Okay, so that concludes my part. So the summary and conclusions. A novel way of data collection and semantic model is the foundation for the semiconductor big data analytics system. Traceability is required for smart manufacturing and process control in a complicated semiconductor manufacturing flow. Exensio provides a data structure, infrastructure, analysis capability, and a closed control loop to enable smart manufacturing with end-to-end big data and AI machine learning solutions for predict and control the process. Okay. Next. So with this, I will hand over the presentation to Benjamin to show you our collaboration with Advantest Cloud. Benjamin.
Thank you, Edward, and I hope everyone can hear me and this is functioning, but I think I would get a signal if not. And let me also thank PDF and the whole team for the invitation and allowing us to show our strategy around Advantest Cloud here to the audience today. And of course, a big thank you to everyone of our customers and of our shared customers, which are the ones that I like the best, for joining here today. So next slide, please. Yep. So when we announced the partnership in July, one of the big questions and thoughts around this was, okay, why are Advantest doing this? And for us, the agenda of the partnership, and it's okay to just move to the next slide, is that we really believe that with PDF, we have a great partner to allow us to do two things. We have one aspect which we think of as Advantest Cloud Solutions, which is a brand and a family of applications that we develop internally, but also with third parties and with PDF together to run and serve our customers and deliver value for them. The other is what we call Advantest Cloud Customer Zero. And we are using the platform Advantest Cloud powered by PDF Exensio internally on our own supply chain. So for many people, sometimes it's surprising to think in the own supply chain, what does that mean? Well, actually, we're a fabless, just as many of our customers are, because we produce our own ASICs for our test equipment. And we deal with exactly the same problems internally, albeit maybe at a smaller scale than some of our customers. But it's the same challenges, the same types of data, the same correlation problems, right? So we are using all of that equipment internally and setting it up in a way that we can get the best use of that for our operations folks, but also, of course, to have a reference organization, a reference installation of the Advantest Cloud powered by PDF Exensio that we can then go out and show our customers and make sure that they get to learn and get to see how it really works, and then can be convinced of the power of the solution. So next slide, please. The key question that we usually get is, okay, I understand PDF Exensio, and I expect that in this call probably most people do, but what is Advantest Cloud and what's the difference? And the easiest way to think of it is how we show it here on the left, is that at the core of Advantest Cloud sits PDF Exensio, and it is just one-on-one PDF Exensio. It's amazing technology that when we looked at the partnership had vetted, and not just us, but also externally, and we really believe that this technology is light years ahead with regards to quality and what it can do. So at its core, Advantest Cloud is Exensio, but there is a red layer that we showcase with this circle around it, because for certain applications that our customers use from us, we actually do add certain components to this Advantest Cloud that are PDF specific. And the good news about this way of setting it up is that if a customer already has a PDF Exensio installation, we can tie into that. So there isn't, a requirement for another full-blown deployment. Instead, since it is all interconnected and we're integrating seamlessly, the customer can just add the missing modules that we might need to add for a certain solution, and boom, it all works together and it can go. For instance, if a customer is using our TE Cloud test development environment in the cloud, he can keep just using that or start using that. And if he's already a PDF Exensio customer, what he can do now is he can take the test data that is generated in a test engineering cloud and can analyze it in Exensio. Solutions that we build on these are of two categories if they have Advantest participation, and that is either standalone solutions or solutions that we jointly develop together with PDF. We have a couple of those already in the market, and you will, as I mentioned later on, learn more about those soon. We also offer our customers to tie into the Advantest Cloud backbone. Why is that? Because we understand that customers have a deep and diverse ecosystem at their existing installations, and this can only work if we tie into that. Similarly, we're talking to third parties and having them develop solutions based on the common set of APIs that sit on top of this Advantest Cloud powered by PDF Exensio. Now, with the equipment integration, we can also do a couple of very interesting things. Of course, the Advantest equipment will be fully and deeply integrated with the agents that collect the data. We're doing, very innovative ways where we go very deep into the equipment and anchor these there, because what we don't want is a situation where you create instability in the equipment by having too many data collection algorithms running from too many different sites, or having them run at levels where they can be harmful to throughput or test stability. On the other hand, we also recognize that not all customers are pure Advantest customers. We would very much like that and encourage everyone to be that, but it's just not what is the reality yet. So we know that by partnering with PDF, we can rely on having third-party equipment also fill in data into Advantest Cloud powered by PDF Exensio, because the full agent coverage that PDF offers is still present there. Next slide, please. So these deep agents that we develop, just to quickly touch on them, we can collect a lot of data from all these different insertions where we have equipment, and there is a lot more deeper and more advanced collection. The control is bidirectional, so we can actually not only read data off of these systems using batch file, or then in the next advanced level would be real time, but we can also control the systems, right? And this is equally important. And we have a whole range of control that we need to enable. You can have maybe control happening on a test floor. You can have control systems sitting in the cloud. But if it is really latency relevant, then you have to move really directly to the edge. And again, we have solutions for that. The agents that we install on these systems are very easy to set up, because they come standardized, bundled into the software packages that we ship with the systems. And so you can set up and run new equipment easily into an existing Advantest Cloud installation. In addition, by controlling the full data stream, we can do some very interesting stuff with regards to stream processing data, but also with regards to certain data types that haven't been available before. that we're making available through this very deep integration of our equipment. So that means that in the center of the semiconductor value chain sits a very powerful cloud powered by PDF Exensio that allows you to correlate data fully, as Edward explained, using a very, very rich and deep set of data available through the tight integration with our equipment. Next slide, please. So let me quickly touch on customer zero. I already mentioned that we use that to in our internal supply chain. We produce our own ASICs and have here one of our high-level assemblies, and all of these now connect through the production workflow into Advantest Cloud. Next slide, please. So some of the challenges. First, let me talk about it from a product engineering perspective, right? So by having the PDF Exensio data lake at the center of all this, one of the main tasks that we take away from the product engineers is that they can focus on their real job. They don't have to focus on making data available. They don't have to focus on shifting bits and bytes around, and they don't have to hunt for clean data, right? There is one single source of the truth. Best practices for you, maybe of interest once you decide to go down on such a project. Hands-on experience is critical. Allow as many of your engineers as early as possible access to the systems. Support the delivery of actionable insights. Not only let them figure it out, but really work with your product engineers to derive actionable reports and then make those available. It's not enough to have found a gem once. Make it actionable, make it so that it looks nice and that it is repeatable and that you can use it over and over again. And stay operational while transitioning from legacy systems. So you all have an existing situation. So key is focus as well on how can I keep it running while I transition, and how can I transition as fast as possible, but don't expect to flick a big switch on a wall at some point where you go from one to the other, but rather shift it over, and that actually accelerates the whole process. Next slide, please. So the other angle, though, is of course the supply chain perspective. We are, as are many, globally distributed, had some very, very, very interesting challenges earlier in the year with the pandemic. But I'd like to say in some part, this already has helped us to manage some of these challenges that we face, because we actually do have cross-reference data, not only from the test side, but also from other data sources put together in this one single source of truth. And now we can actually measure the business impact that parametric data has on our inventories and on our production forecasts, really, really detailed. So capacity planning is a lot more precise. So we can actually deal with unforeseen events that still happen, right? I mean, no big data system is going to, manage the truck driver in Taiwan not waking up in time and missing a shipment. That's just stuff that happens. And you need to have a system that allows you enough slack to deal with that, and that's what we could do. So the assurance of supply is maintained. A couple of best practices. Again, single source of truth is essential. Do not allow any dark data pools to keep popping up, or even to create a couple of new ones. There's always the danger that, in order to focus everything on one system, you just need to put in two new systems to pre-clean data. Don't do that. And talk to your vendors and suppliers as early as possible to allow them to partake in that endeavor. Next slide. So when is this going to launch, and when are we going to learn more? And here we would just like to invite you to Semicon Japan. It's coming up in almost 12 days, so very soon. You can register online. You don't have to, although I would argue you cannot, unfortunately, go to Japan. You can use the QR code on that slide to register. We have a lot of interesting things planned for there. It's a really good digital format. So join us there. PDF will be on the booth as well with us, and we're going to show you a lot more details on the actual Advantest Cloud solutions. With that, I think, yeah, that's a bit about me. We can skip that. I think we're about time, Cheyenne, so I think we can jump to Q&A.
Thank you, Benjamin. We're now going to start the Q&A portion. We'll begin answering the questions submitted during today's presentation. As a reminder, you can still submit questions through the question pane in your attendee control panel. All right, and so Benjamin, our first question is from Tracy. Why do I buy and from whom? What do I buy, excuse me?
So as I mentioned, you know, the details have to be are going to be announced pretty soon. So join us at Semicon Japan. But basically, high level, it is you have solutions from PDF, you have solutions from us, and that's what you're going to buy. You're not going to buy the pure infrastructure. Advantest Cloud is infrastructure that enables solution to deliver customer value, and there are solutions, you know, from PDF, and PDF of course continues to sell its wonderful PDF Exensio products themselves, and the details on exact availability and all of the specs on the individual solutions from an Advantest side are going to be announced later.
Thank you. And Benjamin, Chris asks, does the Advantest Cloud support third-party equipment?
As I mentioned on the slide with the many bubbles, right? We are aware that our customers are not pure Advantest shops, so we use the partnership with PDF and actually to have a neutral partner to enable exactly that, so we can connect to a lot of third-party equipment through the PDF agents.
Wonderful. And Johnny asks, is the Advantest Cloud available today?
So parts of it are in production with early adopters, and we're moving more and more of that into production as well. If you care to know about exact availability and have any interest in exact solutions, please feel free to reach out to your sales rep or to me directly.
Thank you. And we've got another question from Grace here. What additional types of data can Advantest collect with their deep agents?
So I already touched on that a little bit. I think the you know, the depth of data that we are going to be integrating, we would have to go into a bit of a smaller session to talk about that in detail. Again, let me just touch on one thought here is that we generate so much data and test, right? And you always have to disregard a lot of it in order to keep it handleable. And the sooner you can do so, of course, the better, because you can then take the actionable data and generate more insight. And that is something that we're thinking a lot about. How can we enable that? And how can we at the same time, you know, go to the direct data feedbacks and you know, allow our customers to get the most out of it? Because if you ask any data scientist, he always wants all the data. And we recognize that, and we're thinking hard about ways of how we can achieve that while still at the same time keeping it all handleable by the system.
Thank you. And Edward, we actually have a question for you now. So Lucas would want to know how much effort is required to use the PDF semantic data model?
So typically we need the customer with the people who has knowledge of their data. So we interview with them, we do a system integration, and then this typically takes between somewhere around a couple months to maybe half a year.
Thank you. And just as a reminder, you can submit your questions through your attendee control panel through that questions pane. And so Benjamin, we'll go back to you. Wyatt wants to know, is Advantest going to continue or start supporting industry standards like RIT-DB?
Well, we certainly, do, if we see value in them and if we can help our customers using them. That being said, we are not religious about any of those, because if we see and if we feel that going a non-standard way delivers more value for our customers, and we are certainly also capable of deviating from standards. But all in all, we are a big believer in standards.
Thank you. And Benjamin, how will this work with non-tester systems?
That's an interesting point. We believe to be in a unique position in the industry by not only having the most popular test platform, but also having a very powerful family of handler equipment and other equipment like our EVA 100 rack and stack test systems. And we believe if we not only focus on the data signals that we generate in test, but especially also in the data signals that come from a hopeful test cell, we can deliver unique insights and applications that our customers will be able to use. And we believe we are in a unique position to do so by having this tight integration.
Thank you. And Edward, Julie asks, for PDF, how long does it take to implement the Exensio platform in a fabless semiconductor company?
If the data is standardized, for example, implement the agent with Advantest or with like Exensio test platform, this can be much shorter. So we're looking at a month to 6 weeks for the fabless, because the data typically we're getting the sort, we get a WAT, we get a final test, right? But if we also have some customer that utilize like 7, 8 different test platforms, every data is not in the standard format, then this will take much longer.
Thank you. Okay, and that is all the questions that we have today. So thank you, Edward and Benjamin, for presenting today. And thank you, everyone, for attending today's webinar on smart manufacturing with big data. If you have any other questions, please email them to info@pdf.com. Once you leave the webinar, you'll receive a survey on the presentation. We would appreciate it if you could complete that and provide your feedback. You'll also receive a follow-up email within 48 hours with a link to view the recording of today's webinar. On behalf of PDF Solutions and our guest speakers from Advantest, thank you for joining us today and have a great rest of your day.
Thank you.